Hey everyone, welcome to our first online video. Miss Holstein and I hope that you all are doing well, and we want to just remind you to reach out with any questions at any time, and one of us will get back to you. It is best if you email both of us, and then that way we can both see all the questions and be in the loop with everything. So we are going to go ahead and get started. We are starting chapter 8. We did start 8.1 right before everything, but Ms. Holstead and I have decided to go ahead and reteach 8.1 just because it's been so long. So 8.1 is the start of quadratic functions. So the first definition that you need, and you probably already have written down, is quadratic parent function, and that is just that it is f of x equals x squared. So that is the function before doing anything like moving it, adding numbers, anything. This is just the parent function. The shape of the quadratic is called a parabola. It's a U shape. It can be going up or it can be going down. And then the vertex is either the max or the min of the quadratic function. So it's the little point right at the top or right at the bottom. So at the top is your max, bottom is your min. So your minimum is the same thing as your vertex, or your max is the same as your vertex. On the parent function, so the x squared, your vertex is 0, 0, and it's a minimum. Then the next vocab you need for 8.1 is axis of symmetry, and that is just where you can take the U and cut it in half. So if you had a piece of paper, you can fold it in half, and it's the same on both sides. And it's the same thing with a U shape. It is the same here as it is here. Each point is equal distance on either side of that line. Okay, so now we're going to jump over to our guided notes. If you do not have a printer, please feel free to email Ms. Holstad and I, and we can print them and send them to you if you would like, or you are more than welcome just to do them on regular paper and follow along that way. Okay, so again, you should have a copy of these notes, but if you don't, you can either print them from the Word document or my website, or you can just follow along with regular paper. Either way is totally fine. So before we closed, we talked about how this A, if we put it in front here, how it affects the graph. And so we looked at it, and it either makes it shrink or stretch. So it either widens it or narrows it. So the A is the dilation. Okay, so it either shrinks or stretches the parent function. Okay, so then moving on down, we have our first example, and it's asking what is the quadratic parent function and what are its characteristics. So before, we went ahead and plugged in some numbers. We plugged in -2, -1, 0, 1, 2. And when we're doing that, to get our x value, we're going to take, or excuse me, the y value, we're going to take our x and square it. So here it's going to be -2 squared, which we get 4. -1 squared, we get 1. 0 squared is 0. 1 squared, 1. 2 squared, 4. So this is what I was talking about with the axis of symmetry. See, if we cut this graph or table in half right here, we can see that this is 1 away, this is 1 away, this one's 4 away, this one's 4 away. So then we go ahead and graph it. So we have -2, 4 right here, and -1, 1, 0, 0, 1, 1, excuse my lines, and there. And then we draw our U shape. So what is a quadratic parent function? It is y equals x squared. Oops, we are using function notation. So it's f of x equals x squared. What are the characteristics? We have the vertex at 0, 0. So this point right there where we can cut it in half, the middle point, the axis of symmetry. Would be where we can cut it in half, which is right in the middle here. And so that equation for that line is x equals 0. Okay. And then it says, excuse me, where are the values of f of x equals x squared positive and when are they negative? So it's asking when is y positive? And y is positive everywhere except for at that 0, 0 point. Okay. Again, if you have any questions, feel free to email both Miss Holstad and I. So then we did this in class where we matched all of these to one of these here. So I'm going to go ahead and just label them and kind of talk through. So we have, let's go ahead and use a highlighter. So this first one is our parent function. And so that is right here. And then the next one we have, and the parent function we just know based on what we graphed up here. It starts at 0, 0, then it goes 1, 1, 2, 4, and then here we have a dilation of 2 in the front. So it's going to take the y value and times it by 2. So we would go 1 and then it would go up to 2. And then 2 would go up to 8. So it's this red one here. So this is B. Well, that's not going to work. Sorry, still getting used to writing on the computer tablet. And then the next one we want to look at is 1/2 x squared. So that's going to make it go smaller. And so that's going to be when it goes to 2, it would go, instead of 4, it would go to 2 because that's 1/2. So it's this one right here. And for the sake of being able to read the rest, I'm just going to go ahead and label since the graph is a little bit harder to read. So this first one right here, this first line that goes up is your D function. So this one here. And then it goes B, A, C, and this is E over here. And then on the bottom 3, you'll notice there's a negative sign in front, and that means that it just flips this way. So this one here is your G function, your F function, and then your H. So it follows the same pattern of shrinking or stretching. The only thing that changes is it's going downward now. Okay. So example 3, it's asking where is this graph increasing? So increasing meaning a positive slope. So where it's going up, left to right, which from here is increasing. And decreasing would be going down left to right, which is here. And then you go ahead and just write your function or your interval notation. So again, this was going up left to right. And it starts at 0 and then goes to infinity. So 0 to infinity. And then decreasing would be going down left to right. And that starts over here and then goes down to 0, 0. So negative infinity to 0. Okay. Oh. Might have to just erase that. Not sure why that's following. Okay, so then looking at flooring. So here we have the owner of a new dance studio is installing wooden floors, and so we have the area of the dimensions of the floor and then how much it costs. So to find how much it costs, we need the area. So we're going to go ahead and find the area. Finding the area of a square or rectangle is just side length times the base, or height times base, length times width, however you want to say it. So we're going to do 15 times 15, which is 225 feet squared. And then the price of the flooring is $8.75 per square foot. So we're going to do the 225 times $8.75, and we get a total of $1,968.75. Okay, so go ahead and pause the video and try this try it problem. So how much will the cost increase if the side length of the dance floor is increased by 2 feet? So now both sides are being increased, so it's a 17 by 17. Okay, so find the area. 17 times 17, 289. Times that by the price, and you get $2,528.75. But it's asking how much will the cost increase. So we have to subtract those and get the fact that it increases by $560. Okay, last example, and then we are done for the day. How do the average rate of change for this and this over the interval of 2 to 4. So to find the average rate of change, remember that we need to do the y2 minus y1 over x2 minus x1. And so our x's are 2 and 4, but then we have to find the y values. So we actually have to do plugging in 2 and 4 for each of these. So you have to do f of x and do x and y, and you have to find 2 and 4. And then you also have to do g of x and do x and y, 2 and 4. So plug those in and find what you get. Okay, so then after you find that, you're going to go ahead and plug in and find the slope. So we would do this one, it would be 12 minus 3 divide by 4 minus 2. And for that one, we would get 4.5. So now go ahead and do the same for the other one. Okay, and you should get 9. So again, this one we were doing in green, and then this one we were doing in blue. So it says, how do they compare? Well, if we look at it, this one's 4.5, this one's 9. And so they actually doubled. And if we look here, 0.75 to 1.5 is also doubled. So you can say g of x is steeper, or you can say g of x is double the f of x. But really it's kind of just talking about like how much steeper it is. So I hope that this made sense, and I hope that you guys are doing well. Please feel free to reach out to Miss Holstad or I anytime, and stay safe, and just let us know if there's any way we can support you. Thanks. Have a good day.